So for the first one up here, first thing we have to do on each of these is figure out whether it's simple interest or compound interest. So on the first one, find the interest on $5,000 invested at 6% compounded monthly for 3 years. Well, the key term there is compounded. Yes, compounded and compounded monthly. So this is compound interest. So it's going to be that formula, the future value or the ending balance is equal to the principal times 1 plus the rate divided by n is the number of periods in a year to the power of n times t, where t is your years. So that's going to be, what's your principal going to be? It's going to be the 5,000. Good. Times 1 plus, what's going to go in here? 0.06 divided by 12 because it's monthly. And then to the power of 12 times 3. Perfect. Now the 12 times 3 is 36. So this is just going to be in the calculator 5,000 times 1 plus 0.06 divided by 12. Oops, get out of here. To the power of 36. Let's try that again. 1, 2, 3. 1 plus 0.06 divided by 12. $59.8340. What'd you end up with? Okay, try it again. I'll pause here. Let's try it again and see what you can. Okay, now that's the ending balance, but what's it asking for here? Just the interest. So we do have to go back and take that ending balance and minus what we started with, the 5,000, to get the amount that is interest is $983.40. For the second one, find the ending balance on $3,500 invested at 4% simple interest for 5 years. What's the key word here? Simple interest. So simple interest is interest equals principal times rate times time. So it's 3,500 times, what's the rate? 0.04, and the time? 5 years. So 3,500 times 0.04 times 5 is $700. That's the interest. Is that what we want? We're asked to find the ending balance. So we're going to take the $3,500 principal, add the $700 in interest, to get an ending balance of $4,200. Any of you have those first two right? Second one? The second one is the one I would expect you to all be able to do. The first one, I might have a simple compound interest question on the test. Simple meaning kind of like that, either ending balance or the interest. So I'd either want you to find this or to go the next step to find that. The third one is not one I would ever ask you on a test. It would be an extra credit question on that little sheet to hand out after you're done with the test. But no, test is on Tuesday. Unless you want it today. For this one then, find the monthly payment on $12,000 borrowed at 5% for 4 years. You notice it doesn't say compounded, but it's monthly payment, so that implies it has to be done monthly. So the payment is found by taking the lump sum, the $12,000, divided by 1, 2, 3, 1 plus, what's our rate? 0.05, divided by 12, because it is monthly, to the power of 12 times 4, because it's 4 years, minus 1, close parentheses, divided by, open parentheses, 0.05 divided by 12, times, open parentheses, 1 plus 0.05 divided by 12, close parentheses, power of 12 times 4 again, close and close. That happy little formula. Oops, that didn't work well. There, we get 500. Oops, I did something very wrong there, didn't I? Oh, I see it. At times instead of divide, yep. There it is. That should change it. $276.35. Anybody else come up with that? Calculator can't do that? Oh, your calculator won't do that formula. The one-line display, it actually times out. What's that? On your calculator, up in the underneath the screen here, there's arrows right here. You hit the right arrow after you've typed in. I usually just type in a 48 rather than 12 times 4. Then you hit the right arrow and it should drop back down. Yeah. I'm going to leave that one up there for you if you want to. Where did it go? If you want to play with that one a little bit. But then I'm going to put another one up here I want you to try. If you invest let's just say you do $50 a month at 11%, 40 years. How much will you have? So I'm going to leave this one up here so that you can, if any of you still want to, try to make that one work, you can. And then I'm going to give you a couple minutes to do this one down here, see if you can remember the formula for that one. So the formula, when you have regular payments being made in like this, the maturity value or future value or final amount, whatever you want to call it, is equal to your payment amount of $50 times, that's 1, 2, 3. Now your calculator should do this one. The character limit should not be exceeded on this formula, just so you know. You've got a 2-line display. Yours should not have a character limit on it. Oh, go for it. So we've got 50 times 3 open parentheses, 1 plus, what goes next? 0.11 divided by 12, because it is monthly. 480, yeah, 4 times, or 40 times 12, or 12 times 40 is 480 is that power. close parentheses, yep, minus 1, close parentheses, divided by, yep, open parentheses, 0.11 divided by 12, close and close. That's it for that one. Notice the difference between those two formulas is this extra little piece of this formula up here. That'll screw up your calculator sometimes. Some calculators are okay without it. So I've got 50 times 123. 1 plus 0.11 divided by 12. Power of 480. Same answer? Yeah. $430,006.36. So $50 a month is $430 for 40 years. That's not bad. So 40 years, that would mean you started like 25 or so, 25, 27. Now, the nice thing about this formula, by the way, if you double the payment here, that doubles this number. So if you're making $100 a month, that just doubles this number. So once you've got it figured out for $50 a month, every $50 a month you put in is that much plus another 50 would be that much more. And bless you. Okay, enough of that. I'm done preaching on the interest investments. Any questions? You'll be able to use your books and your notes on the test. This one again would be one that I would put on an extra credit sheet, not as part of the main test. So the only two things you'd be required or be expected to know for the main test would be this, the first basic compound interest and then the simple interest. And I'll be honest, I haven't decided for sure if I'm going to put a compound interest on the test yet or not. There will be a simple interest one. What's that? Yeah, we won't do that. I'm not totally sure yet. Usually, depending on my mood, anywhere from 25 to 40. There's a difference between buying and renting. So anyway, so one of the things we've learned, we saw on the calculators, we were able to do those powers using the power key, and we needed them for those formulas we were doing. The opposite of a power, all of our operations have come in pairs. And those pairs are what we call inverses. Like one such pair was addition and subtraction. We saw that addition and subtraction reverse each other. Somebody give me a number between 10 and 20. 15 works for me. Somebody else give me a number between 5 and 10. 9. If I take 15 and I add 9 to it, I get 24. If we want to get back to 15, what do I have to do to the 24? Subtract the 9, gets me back to 15. Adding 9 and then subtracting 9 reverse each other. If I did it the other way, if I did 15 minus 9, I get 6. If I go back the other way, 6 plus 9 puts me back at 15. So not only will subtraction reverse addition, addition will reverse subtraction. It goes both ways. Another pair that we had was multiplication and division. Those are inverses. So if I have 15 times 9, I get 135. I'll give it to you. If I want to get back from the 135 back to 15, I would divide by 9. Gives me 15. if I do 15 divided by 9, that's just 15 over 9, 1 6/9, or 1 2/3, right? If I want to get back to the 15, what do I have to do to my 1 2/3? Times it by 9. So again, division can reverse multiplication, and multiplication can reverse division. Doesn't matter which one comes first. They invert each other. They do the opposite or reverse each other. Yes. Powers are an operation. Exponents include the powers, but if you remember when we talked about order of operations, they also include the roots. Well, powers and roots are another pair of operations, just like addition and subtraction and multiplication and division. So if I have 6 to the power of 2, that ends up being, not everybody at once, there we go, 36. Well, if I wanted to go from that 36 back to 6, we use this symbol. That's the square root. A square root is the opposite of squaring. So that means the square root of 36 would have to be 6. There's one little flaw with that, though. What is negative 6 squared? 36. So therefore, if I square root 36, I should be able to get back to negative 6. Right? Well, the square root of 36 is actually positive 6 or negative 6. There are 2 possible answers for that. Now, as a consequence for this, when we look at these inverses, the inverses can technically be defined in terms of the other operation. For example, subtraction is usually considered to be the inverse operation for addition. Addition is the main operation. When we define subtraction, if I have like 9 minus 2 equals what? Blank. That's usually defined as asking what number plus 2 gives us 9. We can define that subtraction in terms of addition. Yes, we know that's going to be 7, right? The same was true of multiplication and division. If I have 18 divided by 3, what that's really asking is what number times 3 equals 18? And of course, that's going to be 6. Well, the same thing is going on down here with our powers and roots. When I say square root of 36, what that's really asking is what number squared equals 36. Well, because both 6 squared and negative 6 squared give 36, there has to be 2 answers in here. So you'd have to say 6 or negative 6. Now, for our purposes in here, if you only put down the positive answer, I'm okay with that. The plus minus would work, just doing it like that. Yeah, that's fine. Because of that, what's the result of that? Square root of negative 25. 5? Negative 5? Well, do you guys know how to do square roots on your calculator? Yes. Most of you guys have the x squared key somewhere on there. Right above it, there's a square root symbol. So you either have to hit second or shift, depending on your calculator. Hit second, then that key, then type in negative 25. Now make sure you use for negative, you use that minus in the parentheses. You can't just use the subtraction symbol. Domain error. Well, what number squared would be negative 25? Is 5 squared negative 25? No, 5 squared is positive 25. Would negative 5 squared be negative 25? Bless you. No, there is no number that you can square to get a negative number. Any number squared is always positive. You cannot do the square root of negative 25. That's where your calculator gives you a domain error. You cannot square root any negative number because there's nothing that you can square that'll give you a negative result. Now, I say that kind of tongue-in-cheek. We're working with real numbers here. If you were to go on to school and get into like a college algebra course, they would start talking about imaginary numbers, which is literally they looked at something like that and said, okay, we cannot take the square root of a negative number. So we're going to make up an answer to it. We're going to imagine that there's an answer to it. And then we're going to create a whole system of algebra based around that imaginary number. It gives mathematicians something to do pretty much. No, realistically, when you get into electronics, there are some applications in electronics of complex numbers which involve imaginary numbers, like resistance in a circuit. If you're dealing with just resistors and voltages and stuff like that, resistance is very real. But if you have capacitors and inductors in that circuit, it's not truly a resistance, but there is a force that is keeping the current from flowing. So it's called an impedance, which is an imaginary resistance, but it still affects the circuit. So in advanced electronics, there are applications of imaginary numbers. But, outside of that, they are imaginary. So that would be just as useful to you guys as imagining a pink unicorn and what it can do for you. Who knows, right? They can teleport. Tell you what, if you catch one and you get it to teleport, you come tell me about it, okay? There you go. Perfect. You can come and take me to Europe or something. So, will you be offended if I say I'm not going to hold my breath? Okay. So now this one, 4 to the third power, what is that result going to give us? $64, good. So you just use that caret key on your calculator like we have for powers. 4 to the third power is 64. What does that symbol mean? Cubed root, third root. If I ask for the cubed root of 64, what that's asking me to do is what number to the power of 3 equals 64? Well, we just saw that. It's 4, right? So the cubed root of 64 is 4. Could it also be a negative 4? What is negative 4 to the power of 3? It's a negative 64, isn't it? So is the cubed root of 64, can it be negative 4 as well? No, it can't. Cubed root of 64 is just positive 4. Can I do a cubed root of a negative 64? Well, I just saw that's asking what number to the third power is negative 64. Is there a number that to the third power will give us negative 64? Yeah, negative 4 will. To do a cubed root on your calculators, some of your calculators actually have a third root key like that, a cubed root key. All of you will have an X root or an N root key like this, and it's usually on the same button as your caret key or whatever your power key is. So to use that, you're going to have to do 3 first, and then second or shift, and then you're going to do that N root key, which again is above your caret key. And then you're going to type in negative, make sure you use the parentheses key, or the parentheses with the negative in it, 64, and then hit equals. You may have to close the parentheses after your 64, depending on your calculator. Okay, you probably use the subtraction key instead of the negative key. You use the subtraction key? Okay, did you close the parentheses at the end? Here, let me come take a look at it then. So as you can see, we can do a cubed root of a negative number. On your calculator, find the cubed root of a negative 125. What's that? Nope, this one's going to work. What do you get? Negative 5 is correct. Now, a fourth root. Try a fourth root of 625. So instead of doing 3 first, you do 4 first and then go through that whole process. Well, let's see. What is a fourth root of a negative 625? You can try that one on your calculator. What is it? Exactly. Remember that fourth root is asking what number to the fourth power is 625? Well, 5 to the fourth power is 625. Over here, it'd be asking what number to the fourth power is a negative 625. Well, 4 is an even power. If I tried to do negative 5, it would be negative 5 times negative 5 times negative 5 times negative 5. Well, negative 5 times negative 5 is a positive 25. Times the negative 5 is a negative 125. Times another negative 5 is 625. So it is positive. So there is nothing that you can take to a fourth power that's going to give you a negative result. So yes, you have it right on the head there. You cannot do an even root of a negative number. You can only do odd roots of negative numbers. Now on the homework, there was a couple. With the examples, did you figure out what you needed, or do you want me to just go through those two? Okay. So page 97, there are a couple of overhead questions on here. Number 13, purchased a new combine that cost $175,500. So $175,500 minus a rebate of $4,500. So that means $171,000. A trade-in of $9,500. So subtract another $9,500. That's $161,500. A down payment of $5,000. So we're going to subtract another $5,000. So it's $156,500. He takes out a loan on the balance at 8% for 4 years. Now we're assuming he's making monthly payments. Yes, find the monthly payment and the total amount paid on the balance. So the monthly payment is going to be that $156,500 divided by 1, 2, 3. 1 plus 0.08 divided by 12. Close parentheses, power of 4 times 12. It's 4 years. Minus 1, close parentheses, divided by, open parentheses, 0.08 divided by 12 times 1 plus 0.08 divided by 12, close parentheses, that power of 4 times 12 again, and then close and close. Now I'm going to pause there. If anybody needs to write that down, I'll give you guys a minute to write it down. Just a little formula. Amortization, that's just the payment. You can feel yourself growing older as you wait for the formula to get punched in the calculator, can't you? So $3,808.42. That would be the monthly payment. Now to figure out the total paid over that period of time, we would multiply by the 48 payments. Now the book may have rounded off to the 48 or the 3808.42 before they multiplied. I'm just going to leave it in the calculator, multiply by 48. So the total paid is $182,803.96. So what that means is there was about, if you subtracted this from this, that difference would be interest. There's about $26,303.96. Somebody sounds happy. Homework for you guys, and remember your test will be in class on Tuesday. Page 93, 1 through 21, the odds.